Engineering drawings. Rules to follow when using engineering drawings. Do not try to memorize a drawing. Keep only the latest revision of a drawing on file. To avoid damage, handle drawings carefully and store them properly. If there is a question about a drawing, clear it up with the supervisor before proceeding. Always follow the drawing to the letter. Never mark on a drawing unless you are authorized to do so. If you are authorized, sign and date your markings. And last, make sure you read and understand all notes on a drawing before you begin to work. Engineering drawings. There are two types of notes used on drawings: general notes and local notes. General notes are numbered and are usually located at the bottom of a drawing. They apply to several areas of the drawing and are used to avoid cluttering the drawing with individual notes in all of those areas and to save time. Local notes. Local notes apply to one or more particular characteristics on the drawing. They are usually used with a leader line pointing directly to the characteristic, or they may be flagged. To recap, general notes are numbered and located at the bottom of drawings, apply to several areas of the drawing, avoid cluttering the drawing. Local notes apply to one or more particular characteristics, are used with a leader line pointing to a characteristic, and are used with a triangle flag with a number, which is usually a note at the bottom of the drawing. Under the topic of planning and preparation, we will start discussing engineering drawings. This slide shows an example of an engineering drawing. Those working in the industry must understand engineering drawings. These drawings relate design requirements to operators, machinists, inspectors, assemblers, and many others who use engineering drawings to make, inspect, or assemble products. Therefore, drawings are the industrial language. It is the intent of an engineering drawing to describe clearly all requirements the product must meet to be a quality product. Many quality problems occur solely because someone did not understand how to read or interpret a drawing. To avoid getting involved in these problems or causing them, it is necessary to understand how to read and interpret drawings. Drawings are made up of various lines and views that are easily learned. Once you learn these, you will be halfway to learning how to read engineering drawings. Engineering drawings, change blocks. The change block is usually shown in the upper right-hand corner of a drawing, and generally the information given in a change block will be given in table form. In this table are the topics of revision, the zone, the description of the revision, sometimes called the revision, the date, by, and approved. The rev is the latest revision of the drawing. The zone is the drawing area in which the change was made. The description or revision describes the revision that was made, what the specific change was, and the extent of the change. The date is simply the date given, or when the revision was in effect. By is the person who made the revision of the drawing, and approved is the person who approved the revision. Tabular dimensions, or tabular dimensions. There are times when several similar parts are made with only slight differences. An example of this is when several washers are produced and the only difference being the inside diameter of that washer. The washers usually have the same basic part number but have a different dash number to identify them. When this is done, tabular dimensioning can be used effectively to save time in preparing a different drawing for each washer, as shown in the drawing on your slide. Engineering drawings, title block. The title block of a drawing is usually in the lower right-hand corner of the page. It contains information that identifies the part and other particulars about that part. There is no standard arrangement for the information in the title block, but there are standard pieces of information found in it. Some of these are part name, part number, material to use, next assembly, title block tolerances, the draftsman, the checker, company name, scale, and size. Drawing lines. The first line we will discuss is the object line, which is usually a heavy, solid line. An object line is used to show the outer and inner boundaries of surfaces and features in a particular view. Next to that is a hidden line. A hidden line, which is short dashes of equal length and spacing, are used to show surfaces and features that exist but cannot be seen in a particular view. Next is the center line. The center line consists of long and short dashes and is used to show the geometrical center of an object. Next is a leader line, which is a medium to solid arrow. It's used to point or lead the reader from a dimension or a note to the feature or surface where the dimension or note applies. Next is the extension line, which is a light solid line. Extension lines are used to extend a feature or surface from the view so that it can be dimensioned. Next is a dimension line. The dimension line is a light solid line with arrowheads on each end of it and are used to dimension the part or to show the distance between the extension lines. Next is a section line, which is a light solid line and is usually 45 degrees and equally spaced. They're used to show the surface of a part that has been sectioned or cut. Next is a cutting plane or viewing plane line, which is a medium broken line, used to show where a part is to be cut and the direction of the view. If you notice with the cutting plane view line that it cuts the part in half and implies the direction that the part is to be viewed. Short break line. Looks like a medium jagged line, often used to break up a particular view and show some of it in a section. Next is the long break line. It's thin and used to break up a long object along its length. Phantom lines. A phantom line is used in four main ways. 1. To show an existing structure that needs modification. 2. To show alternate positions of an object. 3. To avoid unnecessary detail. And 4. To show the direction of a unilateral profile tolerance zone and geometric tolerancing. Orthographic projection views. On engineering drawings, various views are used to pictorially represent the object. Many different views are used for this, but the main ones are front, right side, left side, top and bottom. The most important view of all of them is the front view. After the front view is chosen, using it as a reference, the right side, left side, top and bottom views may be used. Readers must understand the views on a drawing. They must be able to fold them together in their mind and imagine what the real object looks like. For example, the object in the slide is a picture of a cardboard box that has been cut. The slides have been folded out in the same way that the drawing views were folded from the front view. If you look at the upper left, this is a box with sides folded out, and on the right is the box itself. In addition to an orthographic projection view is the isometric view. An isometric view is a three-dimensional display of the part that can help readers to visualize the part without having to fold the main views in their mind. An example of an isometric view can be seen on the right-hand portion of your slide. Detail views. A detail view is often used when the scale of one of the main views has features that are difficult to see. You will see that this particular area of this view is circled and a line is extending from the circle and refers the reader to a detail view. For an example here, detail A. The detail view is drawn separately and enlarged for easier reading. Engineering drawings, feature control frame. Many older drawings controlled geometric tolerances by displaying a note such as all surfaces parallel and perpendicular to each other within 1/1000th of an inch. Today the method used to specify geometric tolerances is a feature control frame. A feature control frame consists of a rectangular frame that is divided into two or more compartments. The first compartment of the feature control frame contains a geometric characteristic symbol. The second compartment of the feature control frame contains the tolerance. Where applicable, the tolerance may be preceded by a diameter symbol. The tolerance may be followed by a material condition symbol. The tolerance may also be followed by a datum reference letter. And finally, when a feature that is controlled by a geometric tolerance is also the datum feature symbol may be placed on the feature control frame.